Welcome back. In this video, we're going to look at the graphs of polar equations. The graph of polar equations r equals f of theta consists of all the points that satisfy the equation. To plot points in polar coordinates, it's convenient to use the polar grids shown. Here's a graph. It's kind of like graph paper, but it looks kind of like bullseye, where each one of these concentric circles is the radius defined. So every time you count out from the center 1 notch, that's like 1 unit for the radius. Let's take a look at this first example. We're asked to sketch the graph of the polar equation r equals 6 cosine of theta by filling out the table. First, we're going to fill out all the values for r given these different theta values. Now think about this in terms of the fact that we're substituting theta in, and r will equal 6 times that cosine of that angle. 6 times cosine of 0 is 6. 6 cosine of pi over 6 is root 3 over 2 times 6. The next angle is pi over 4, so we have r equals 6 times cosine of pi over 4. That will give me 6 times root 2 over 2. The next one is r equals 6 times cosine of pi over 3, which will give me 6 times 1/2. The next one is r is equal to 6 times cosine of pi over 2. At this point, I'll have 6 times 0. The next one will be r equals 6 times cosine of 2 pi over 3, which will give me a 6 times negative 1/2. The next one is r is equal to 6 times the cosine of 3 pi over 4, which will give me 6 times negative root 2 over 2. The next one is r equals 6 times cosine of 5 pi over 6, which will give me 6 times negative root 3 over 2. And lastly, r equals 6 cosine of pi, which is equal to 6 times negative 1. Recall that the coordinate points for polar graphing will be r and then theta. My first radius is r is equal to 1 times 6, which is just r equals 6. The next one is r equals 3 root 3. The next one is going to be r equals 3 root 2. The next one is r is equal to 3. And then r is equal to 0. The next one is r is equal to negative 3. For 3 pi over 4, our radius is 6 times negative root 2 over 2. That will give me a negative 3 root 2. For 5 pi over 6, we have 6 times negative root 3 over 2, which will give me negative 3 root 3. And lastly, 6 times negative 1 is just negative 6. We need to think about how to make sense of this by plotting all these points. We have an r, and we have a theta for each one of these. And so first, remember how I graph these. I stand at the origin. There I am standing at the origin. And I am going to look out along the polar axis, which is at 0 radians. And then I'm going to rotate through an angle, which is 0 at this point, and then walk out along my angle 6 units. 1, 2, 3, 4, 5, 6. This is where my first point is. That is the point 6, 0. I'm starting back at the origin, and I'm going to rotate pi over 6. So now I'm looking out this direction in the first quadrant, so to speak, and I need to walk out 3 root 3. Now some of you might not be familiar with that as a unit, so I'm going to quickly graph what that value is. 3 second square root 3 is going to give me 5.19. I'll just go ahead and round to 1 decimal place, so 5.2. 1, 2, 3, 4, 5.2. So there's just a little bit past. There's my next point. I'm going to continue to do this. You have to think of this as being mapped out away from the center of this polar graph. The next coordinate point I need to find is pi over 4. So here's pi over 4. I need to walk out 3 times root 2, which is 4.2. 1, 2, 3, 4.2, right about there. Now I'm going to go on to pi over 3. At pi over 3, my radius is 3. I'll count out 1, 2, 3. There's my point. At pi over 2, my radius is 0. Next, I'm at 2 pi over 3. So I'm looking out this way, but notice that my radius becomes -3. So now instead of moving out in the positive direction, the way I'm looking, I'm going to back up 3. So this will be 1, 2, 3 in the opposite direction. And I hope you can see how this becomes kind of this symmetric shape. The next value is 3 pi over 4 is the angle. And I'm going to back up -3 root 2. And then the next one is 5 pi over 6. So I'm looking out this direction, but then I'm going to back up 3 root 3. And then at pi, which is looking out along the negative x-axis, I need to back up 6. 1, 2, 3, 4, 5, 6, which is where I started. And I think that you can see that if I were to connect these dots, I would get this very nice circle. In general, the graph of equations of the form r equals 2a sine theta and r equals 2a cosine theta are circles with radius absolute value of a centered at the points with polar coordinates a, pi over 2 and a, 0 respectively.